name is Shavana, and these are my teammates Alessandro and Uber. For our senior design project, we plan to design, manufacture, and assemble the differential for the FIU Formula SAE Racecar. This is a basic outline of the things we'll be discussing with you today. In designing the differential, there's various components that we will be held responsible for. Some of them from this picture include the differential gears, friction plates, and the axle for the differential gears. In addition, since we're changing the design from the current car, we will also need to redesign the housing, the mounts to secure the differential to the chassis of the car, and the sprocket. Our motivation for this project is to have FIU do well at the FSAE competition. I'm sure you all know that the FSAE competition is a very prestigious competition that engineers come from all over the world to compete in. One of the things that we will have the opportunity to do is to have our design seen and judged by top engineers from across the world. Our ultimate goal for this project is to optimize the differential for the car, since the one they have right now is just an off-the-shelf stock differential, and we plan to try to optimize power transfer from the engine to the wheels of the car. This is the basic division of responsibilities. As you can see, everyone will be responsible for different calculations in the design of components. For example, I'll be responsible for housing and spacer design. Uber and I will work together to do the SolidWorks modeling and simulations, while Alessandro will take the lead when it comes to prototyping and manufacturing. Our project timeline. We plan to utilize the summertime for design, analysis, and simulation, so that way when the fall comes around, we have a lot of time to devote to manufacturing the components and testing. We do plan to spend a lot of time testing this design.
Our main goals is, primarily one, is to reduce the weight from the current differential by at least 15%. This we're planning changing the differential type that we're using this year for the 2015 Formula SAE competition. This year we're using a T1 differential which is able to support until 500 horsepower. Also, why we would like to change the differential to a T2 because this is the differential type that is used by the top teams in Formula SAE competitions. As well, with this design we can reduce the backlash, and as well that we can reduce the backlash, it's more durable. Also, we have to maintain the current torque bias ratio. There is a 4:1, where it's at the best performance, you can have 80% of the torque in one wheel and 20% of the torque in the other wheel. By reducing the weight, we also want to change the materials used for the housing and the gears. So we can reduce even more than 15%. For the constraints. For this, we have to follow the 2016 Formula SAE rules, not the 2015. Also, we have to follow and stick with the two critical tests. There is a static test and a dynamic test. The static test is a 45-degree steel test for the differential where it cannot leak. Well, it's in the test, as well as the dynamic test. There is an endurance race. There is a 22 kilometers race where after you finish it, all the judges have to follow and see that is any leakage during the track. We have to withstand with the engine specifications, so they don't have to make any major changes to it. So we gotta adapt to the engine. Also, this will follow us for the location and size of the sprocket. The location and size of the sprocket also will affect the dimension of the axle and the joint angle, because we cannot have too much angle in the joint, because this will reduce the performance of the car, as well as we have to follow the cost, because changing the materials, having lighter materials, and as well as parts, this will really affect the budget of the design.
Now, for design considerations, we'll try to design the differential to get as closer to the sprocket of the engine. This will reduce the angle of the CV joints. That way, the energy transfer is more efficient. Also, on our consideration is engine development. We'll design a differential capable for the engine team to increase in performance and horsepower without having to change the differential itself. Also, we'll design an interchangeable sprocket in a way for so the team can change sprockets without having to redesign the differential. That way, in testing, they will choose the size that best fits them. For design alternative 1, we have chosen pure warm gear meshing in parallel. This will give us the differentiation in the wheels that we want. Also, the locking effect that's capable with because of a warm gear meshing. Now, for design alternative 2, it's pretty much like an improvement of design alternative 1, where we're going to add friction plates between the gears and the housing, and friction plates between the two main gears. This will give us a higher torque bias ratio. Design alternative 3 is the next step in torque bias ratio by adding preload springs in between the main gears. This will give us the highest torque bias ratio, also modifiable torque bias ratio depending on the preloaded springs. However, the downside is that it is the most complex of all three alternatives, increases cost of manufacturing and maintenance. As you can see, this is the exploded view of the design alternative 3, where the preloaded springs are in between the main gears with pretty much all the friction plates that were in alternative 2.
For the designing of this differential, we have to follow many standards, as well as the American Society of Testing and Materials. This will let us know as soon as we choose the material that we select to do the gears as well as the housing. This will let us which standard we have to use, the dimensions, and all this, as well as the American Gear Manufacturers Association. This will apply to the gears, coupling, and all the parts of the power transmission. This will affect directly to the sprocket. Also, we have to follow the formula, the SAE standard. This will let us know the lubricants that we have to use for the differential. We cannot use any lubricant, just the one that they say. So this will affect some parts of the gears as well as the material used. So we are dealing a lot with the globalization. So we are trying to design for manufacturing in various parts of the globe. This also forces us to use universal units, as well as try to make a manual in different languages. Because if we are trying that the design can manufacture in every part, we have to, as well as the sample, needs to be in different languages as well, using universal units, so that people don't have to change all this, losing time in that. Also, the cosmology for different regions in different currencies because of the materials used. We all know that the materials that can be used for the differential are not the same price in every part of the world. So this will affect really the price of the. For the conclusion, for summarizing, we have for this year on this project, we are designing, manufacturing, and assembling a differential for 2016 FIU Formula SAE car. The main reason is try to optimize the drivetrain, reducing weight, and always trying to maintain the torque bias ratio of at least for this year, but reducing the weight and changing the type of differential. We also forcing to reduce the backlash and making a more durable differential. You're very welcome to make that question. Thanks.
Thank you. How's this coordinated with all the other components? And who's in charge of that coordination?
What other components?
Well, this is just the gearbox, correct? Or the
Yeah,
differential?
Yeah.
So how is that coordinated with the engine, and how is that coordinated with the axle and the wheel, the transfer of power to the wheel and all of that?
All right. I'm gonna go back just for pictures. This is pretty much our the differential, and as can be seen, it has to be aligned with the sprocket of the engine that's mounted in the chassis. As wheels go, the CV axles that transfer power from the differential to the wheels. That's pretty much all the correlation that we have. On our design considerations, on our design constraints, we have the dimension of current drive axles, shafts, and CV joint angles. This is because the CV joint has a maximum angle that they can achieve before failing. For that reason, we'll try to approach the differential as much as we can to the engine in order to reduce this angle that you can see here.
Well, the real rationale behind my question is, to what extent is this going to be integrated in the whole to make sure that the efficiency is maximized? So in other words, you're not a detriment to the efficiency goal. How well is that coordinated?
Well, we'll try to make it more efficient by reducing the weight, because and make it custom made for this type of vehicle, because the differential that's now in use was taken pretty much out of the shelf for a 500 horsepower engine, and this as much can make 100 horsepower, so that is added weight with pretty much no purpose.
All right, so I'm assuming the engine side mounted where your drive is parallel to the wheels, right? So
Yeah.
you don't have a pinion and gear. And ring
No,
gear.
we don't have a pinion in gear.
All right, so my question is, you have a ring gear there. What does the ring gear do in that design?
No, in the this
There's
will
no
be,
ring gear there.
No,
Right,
it's
okay.
just a sprocket. This is the picture of
A standard.
a standard,
Right,
yeah,
okay.
out of the shelf. That's why we need to modify it in order to incorporate a sprocket.
Well, that makes it a lot simpler as well, but you were saying that you could change the sprocket size and all that, but I'm assuming that you could calculate the final drive ratio by the diameter of the disc, so you would have an idea beforehand what
Yeah,
would be
yeah.
your optimal gear size, right?
Yeah, that will be calculated, but as seen in competition, most of teams actually are like start in second gear.
Okay,
That's because
so very high.
yeah, that way
Ratio.
they can, they take less time by
More torque?
changing gear and pretty much being faster out of the line. Well, not out of the line, but as the course go.
So why have a first gear?
Well, because
There's some situations where you win on the first gear.
yeah,
And also it says that it can't leak. That's a CO unit, right?
yeah, we need to seal it
And you
because
could go upside down and not leak.
yeah.
But my question is, you actually gonna manufacture the gears and everything yourself? Or
We'll
you gonna use
try.
off-the-shelf gears and assemble them?
We'll try to get as much out of the shelf gears as we can. If we see that there's there are we cannot find any gears, then we'll try to ask for companies to manufacture it.
That's
for our-
complex,
Yeah.
yeah. All right, so,
Did I see a cost breakdown somewhere, or did I miss it?
For the cost?
Cost
No.
breakdown.
huge.
Yeah.
I compare it off the shelf to make it.
Yeah, but that's the side, that's the downside of custom making some, custom, building something for a car.
We will try to reduce the cost.
They don't make like lighter, I know that you need the engineering exercise to do all this, I mean, that's fine. But they don't have an off-the-shelf for 100 horsepower, I mean, you still have to have a safety factor in there of, like, I would make it
Yeah,
like
yeah,
200 horsepower.
Yeah, we'll design for a safety factor. However, what we find out of the shelf is for Mustangs and
Really?
that type. Yeah,
They don't make them like for Polaris devices or anything like that?
no.
All right.
Any other comments? Aaron?
Let me see your standard slides, just for another minute, please.
Oh, sorry.
Okay.
Thank you.
Aaron had a comment.
I don't know a lot about cars,
That's all
there you
right.
go. But I'm a little curious as to how you're going to test, apart from just placing what you're building into current car or something. So when you're saying designing a housing for the T2R differential, do you know how you're going to, make sure that that's going to last for X amount of time? And how will you test what you're building?
Well, the testing, what we will do is place the vehicle in a dyno, and that can sense the power at each wheel, and that way we'll have a pretty good measurement of the torque at each spinning wheel.
Okay, and what are you testing for, apart from, I know your design objectives is, reducing the weight and keeping the torque ratio, but are you only testing for withstanding engine specifications? Is that the only thing you're looking for?
No, we'll design based on engine development, because we don't really know right now the torque produced by this engine, but we'll know in this couple of weeks that we'll put it in a dyno. But as we know, engine development will increase the horsepower throughout the years, and we don't want them to have to change the differential because they increase the torque or they increase the horsepower. So we'll design our differential based on a certain amount of we'll design based on torque that top teams have right now, and that's the torque that our engine development team will try to achieve.
Okay, so you have a test matrix in your mind already?
Yeah.
Okay, so,
So you do have access to, is there a dyno on campus?
Yeah, there's
That
a
went
dyno.
for the wheels as well?
Yeah.
I didn't have that back then.
Times have changed.
We only have one for the engine itself.
Okay, thank you very much.